Welcome to Ask and Learn.
So in this problem, we're given a bowl that is 30 centimeters in diameter, and we drop a 10 centimeter diameter ball in this bowl, a heavy ball. We begin to fill it with water, and the water level in here, right, is at some height h. Okay, and the question is for us to figure out the formula, find the volume of water in the bowl based on that depth h. Okay, so first of all, we know that for the bowl, the diameter is 30 centimeters, so therefore the radius is 15 centimeters. Okay, let's assume that we do this, right? We have the origin be at the very bottom of the bowl here, and the x and y axis go through the middle of it, just like that, drawing right there. Okay, then using the center radius form of a circle, this equation of this bowl, because it's a hemisphere, so it's half a circle, right, is x squared plus y minus 15 squared. I guess I should have put my x-axis up here at the top. 15 squared is equal to 15 squared. Okay? So, as I've said, we'll put our x-axis up here. Okay? Now, let's calculate this for values of x then, right? So this is x squared plus y squared. Actually, we'll just say that x squared equals 225, that's 15 squared, minus y minus 15 squared. And so then x is 225 minus y minus 15 squared, the square root of that. And this is going to be for 0. It's going to be valid for 0 is less than or equal to y is less than or equal to 15. Okay? Now, which matches? We can't have a height greater than 15 centimeters because our bowl is only 15 centimeters, right? So then the volume is going to be found by rotating these values, rotating this with respect to the y-axis, isn't it? Right? Just rotate those y values around or those x values around the y-axis. Okay? So that means I end up with pi times the integral from 0 to h of the square root of 225 minus y minus 15 squared and you square this, pi r squared dy, right? Okay, so that means then that I get pi times the integral from 0 to h of 225 minus y squared minus, see, it'd be plus 30y minus 225. All of this dy. Well, 225 minus 225 cancels out, doesn't it? Okay, so that means I have pi times, let's see, the integral of 30y is 30y over 2, and that's y squared, minus y cubed over 3. We're going to evaluate this from 0 to h. Okay. Well, when I put in 0 in there for y every time, that's all 0, so that's all can't drop out. And so that means I'm left with 15 h squared. Let me do it this way. Let me do it this way and make it clear. Pi times 15 h squared minus h cubed over 3. Okay, and of course this is from 0 is less than or equal to h is less than or equal to 15. So this is the volume in the bowl. Alright, so similarly we do the same thing for the ball. Right? For the ball, we have diameter is 10 centimeters, and so the radius is 5 centimeters. Okay. Again, doing the same thing like we did earlier. We have the ball here, our x and y this way. Okay. So we write the equation for that circle. Well, that's x squared plus y minus 5 squared is 5 squared. And so that means x is 25 minus y minus 5 squared. Sorry, that's x squared. So then x is the square root of 25 minus y minus 5 squared. All right, so rotate this. Rotate with respect to the y-axis on this to do the volume. And then we have the volume of the ball is pi times the integral from 0 to h of the square root of 25 minus y minus 5 squared, pi r squared, right? dy. Okay? And so this is pi times the integral from 0 to h of 25 minus y minus 5 squared dy. And so this is pi times the integral from 0 to h of 25 minus y squared plus 10y minus 25 dy. And 25 minus 25 is 0, so those cancel out. And so I end up with pi times doing the integral of 10y, so that's 10y squared over 2 minus y cubed over 3, evaluated from 0 to h. Okay, so that means I have pi. When you put 0 in there for y, that's gone. So this is pi times 5y, or not y, it's h now, right? H squared minus h cubed over 3. Okay, and this is only valid from 0 to h to 10, right? With h between 0 and 10, because the diameter of the ball is 10. All right, so the volume of the water in the bowl is the volume of the bowl minus the volume that the ball takes up at any point in h, right? So for 0 is less than or equal to h is less than or equal to 10. So for a height of 10 centimeters or less, then we have the volume of the water is our two formulas together. So that's pi times 15h squared minus h cubed over 3 minus pi times 5h squared minus h cubed over 3. All right, well, so distribute this out in here, and what do we see? We'll see that this and this will cancel out, and so we'll have 15 pi h squared minus 5 pi h squared. So we'll be left with 10 pi h squared is the volume of the water for 0 is less than or equal to h is less than or equal to 10 for the first 10 centimeters of height. So then for 10 is less than h is less than or equal to 15, right? Then the volume of the water is the volume of the bowl minus the total volume of the ball. So that means I have pi times 15 h squared minus h cubed over 3 minus the total volume of the ball, which is 4/3 pi r cubed by definition of a sphere. Okay, so since the radius is 5 centimeters, this is pi times 15h squared minus h cubed over 3 minus 4/3 pi times 5 cubed. Well, 5 cubed is 125. Okay? So, that means I'm left with 15 pi h squared minus pi h cubed over 3 minus 4 times 125, so that's 500 over 3 times pi. And so there's the formula, right, for 10 is less than h is less than or equal to 15 for when the height is over 10 centimeters. And this is the formula when we're from 0 to 10 centimeters height.